Amazon Simple Notification Service, or SNS, is a managed service that provides message delivery from a publisher to a subscriber. Publishers communicate asynchronously with subscribers using messages. SNS supports application to application or application to person communication. The application to application functionality enables sending messages between microservices or distributed applications and use that as a means of communication, whereas the application to person functionality enables sending SMS, emails, etc. In this video, let's learn how to get started with Amazon SNS from a .NET application. We will learn to create topics and send messages to that, use subscriptions to receive messages, set up filtering, error handling, and a lot more. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud, and DevOps. Now, without much delay, let's get straight into Amazon SNS. Here, I have an ASP.NET Core Web API default template using the .NET Core 6 template. Now this has the program.cs, the weather forecast class, and also the weather forecast controller. Now this controller by default has a get method which returns some dummy data. Now let's assume we want to add a new post method where we can post a weather forecast object into our application. Now once a new weather data is added to our application, we might want to kick off a few other processes. Let's say we want to send an email, or we want to recalculate some reports, or any other business functionality that you might want triggered. Now in these cases, it's best to use an Amazon Simple Notification Service or the SNS. So let's first add the HTTP post method. So for that, let's create the HTTP post. Let's specify the function name. So let's call this as public task. Let's name this as post itself. Let's take in the weather forecast object as the data. Now this is going to get bound from the body of this request. Now once we have the data here, we could do some application processing like validation, storing to a database, etc. So once that is saved, you could publish a new message to the SNS. Now, if these processing takes a longer time, you could also publish this message itself to an SQS queue. We learned about that in my earlier video on SQS. If you're new to that, I highly recommend checking that video linked here or in the description below. Now once the application processing is done, let's assume we just need to raise an event in this case. The event could have the complete data, or it could also have a subset and have a weather forecast event specifically. For this example, I'll simply use the data object itself. Now you could go and create different classes like weather forecast added or weather forecast updated event, etc. based on your application needs. To send to an SNS, we first need to create one. So let's head over to our AWS console and create a new SNS. Since I recently used this, it's there in my recently visited. You could also use the search and search for SNS and select it from here. So this is Simple Notification Service in the console. Now inside that, we can start creating a topic. To get a very high level overview of the SNS, here we have the publisher, which is going to be our API application that's going to publish the message once the weather data is added. It's going to publish into the Amazon SNS ecosystem, which comprises of the SNS topic and also the subscriptions for each of these topics. Now this topic is where the publisher sends the message, and then that is getting received by the subscribers using the subscription. So let's get started by first creating the topic so that we can send the message to it. So let's come back and create a new topic. Let's call this YouTube-SNS and create the next step. Now this gives you an option to choose between standard and FIFO setup for your SNS. Now for this video, I will be using standard. In a different video, we will learn about the features of the FIFO or the first in, first out capabilities. So the name is YouTube SNS. The display name, if you want, you can choose one. So let's name this again as YouTube SNS and leave everything else as default. We will get back to some of these options later in this video. So let's click Create Topic which creates the new topic successfully. So now we have a YouTube SNS to which we can send messages. An Amazon SNS topic is simply a logical access point that acts as a communication channel. A topic lets you group multiple endpoints, which is basically multiple subscriptions. So if you have a message that needs to go to multiple subscribers, you can send this to a topic, which is exactly what we have just created. So let's come back to our ASP.NET application and send messages to this topic. We need to create a client to send messages to the topic. Now this client is the Amazon Simple Notification Service client. So let's type in Simple Notification Service client and look for the options that Visual Studio is giving. It has automatically detected from this type name that this is coming from the AWS SDK.Simple Notification Service NuGet package. So let's find and install the latest version into our project. You can also go into Project and click Manage NuGet Packages and specifically install this NuGet package. This class has multiple overloads. Let's take the one that takes in a credentials and a specific region endpoint. So let's specify credentials, which we will create in a moment, and specify the region. Now if we come back into our portal, go to the Simple Notification Service, you can see the region here. Now in this case, I have created it in North Virginia. Now this is the US East 1. So let's come back the code and specify the region endpoint and specify US East 1. Let's close this and create the credentials object. So let's create credentials is equal to new basic AWS credentials. Now this allows us to simply specify an access key and a secret key, which we will create in a moment later. For demo purposes, I will be hard coding the access key and the secret key in the source code here. However, in a real-world application, you should not be checking in sensitive information inside your code. I have a separate video where I show you 5 different ways to manage application configuration and sensitive data when building applications. I highly recommend checking that out, which will be linked here or in the description below. Now that we have the client created, let's use this to publish messages. So we can use the publish async method to publish a new message. You also have the publish batch async, which is basically to send multiple messages. So let's use the publish async and specify the new message. Now this again has multiple overloads. Let's use the one that takes in a publish request. So let's specify the request and create a request right above this. So let's make this as a new publish request, which is what the method expects. So this again comes from the Amazon Simple Notification Service .model namespace, which is inside that NuGet package that we installed. So let's make sure to add the using and create this new request. Now inside the request class, you have multiple properties. Some of the important ones are the topic ARN, which is the topic that we want to send this message to. We also need to specify a message, and also if we want, we can specify a subject. For the message, let's serialize this data as JSON object and send it as a string. So we can use the JSON serializer. Make sure to include the appropriate system.text.json and call the serialize method on the data object. This serializes it into a JSON object. Now we can also specify the subject and specify new weather data added. This is the event name in this particular case. Let's make sure to add an await to this call and also make sure this has an async inside the main method call here. Now I'm using Control dot or Alt Enter to open up this pop-up in here. This is easy so that you don't have to manually go and check this button here. If we want, we can also take in the response and store it as a variable and use it for something inside our application. Now with this set, we can now create the basic credentials that's required so that our application can connect and send messages to this SNS topic. So let's come back to the portal. So let's make sure to open a new tab. Let's go into IAM, which again you can search from this bar here. So let's come into users and create a new user. Let's name this as YouTube-SNS and specify that we need an access key, which will give the access key and the secret key for this user. Let's click next For now, let's skip any of these groups. So let's specify next and skip adding tags. Now you could add these if that's required in your organization or in the team that you're working in. Now currently we don't have any permissions, but we'll add them soon enough. So let's click create user, which will create the new user. This gives us the access key and also the secret access. So let's copy both of this into our clipboard. Let's come back to our application in Visual Studio. Let's paste the access key. Let's hit the Windows and V, which will open the clipboard manager, and select the secret key that we copied earlier. Now we have the access and the secret key. Like I mentioned, you should not be hard coding this in here. You should be securely storing this, which could include the AWS parameter store, which can defaultly integrate with the .NET configuration providers, and it's easy to use from applications. So let's leave this here for demo purposes and move on. Now for the topic ARN, we can come back to our topic and copy this from the ARN here. So let's copy this and paste it inside the topic ARN. Now with the credentials and the request set up, let's make sure this user has access to publish to this SNS topic that we created. So let's come back, let's go into the IAM, select the user that we just created. So let's select YouTube SNS and create permissions for that. So we can create an inline policy for just giving access to the SNS topic that we created. So let's select the service and choose SNS inside here and select this. Now based on your application needs, you can pick and choose the access level that this user has to this SNS topic. For now, I will be giving all SNS actions, which gives all the actions that's listed here. We can specify the specific resource, which is the specific ARN that's to be used. So let's click specific and say add ARN. Now we already have the ARN in our clipboard. So let's paste that in here and click add. Now this is going to give specifically to this ARN all these actions for this user. So let's click review policy and give this a name. So let's specify YouTube SNS user policy and click create policy. Now this gives the permissions for this user to do any action on this particular SNS topic or subscriptions that we create in the future. So let's come back to our application, run this to see this in action. Now I already have a breakpoint here and the application is running successfully. So we have the get and post endpoints. So let's expand the post, click try it out, which already has the data populated here, and click execute. Now this sends the message. We have the data as expected, and this is creating the publish request. So let's step through this and call the publish async method. Now this sends the message to the SNS topic and gets back a response. Now if we expand this, we can see this is an OK response, which means the application successfully published this message to the topic. So let's continue the execution and come back to our topic inside the AWS portal. Now if you go into this topic, there is no way to see the message that we have just published. This is because we currently don't have any subscribers that's listening to this topic. To receive a message that is published to your topic, you must subscribe an endpoint to this topic. So only once you have added the subscription can you start consuming these messages that's sent to these topics. So let's see how we can add a new subscription. So let's come back to our SNS. Let's click the create subscription under that, and you can see the option to create a new subscription. Now this supports different protocols to create the subscription. You could send messages to a SQS, a Lambda, email, HTTP, SMS, etc. Now you have multiple options in here. So based on your application needs and other integration points, you can directly create subscriptions here. Now to get started easily, let's choose email JSON, which is going to send the whole JSON payload as an email. So we can specify an email inside this. Now I don't want to use my personal email to show this test. So let's go into a service which is called Mailinator, where I can create public email boxes and use that for testing. So using this service, I can simply enter a random name and make that as an inbox. So let's specify YouTube-AWS-SNS, which is going to be my email. So let's click go And this sets up a new inbox for me with the email as youtube-aws-sns@mailinator.com. So let's come back. To our subscription, specify this and give the mailinator.com as the email and click Create Subscription. Now this adds a new subscription, but this is awaiting confirmation from the email that we just added. So if we switch back to the Mailinator inbox and refresh this, we already have the email from here. So let's click into that email and make sure to click this URL, which is the subscription URL. Now this confirms that we are accepting this SNS subscription into this email. So if we come back to the console and refresh this again, you can see this subscription would be confirmed. Now the next time we send a message, an email would be sent with the JSON payload to this particular email. So let's come back to our application, update this text. So let's say email test and click execute. Now let's remove this breakpoint and press F5. Now this message is successfully sent to our topic and we have a subscription that will automatically send it to this email. If we come back to the inbox, we can see there is a new email which says new weather data added. Now if we select into that, we can see the exact message that we sent to the topic. Now all of this is the additional metadata, but you can see that the summary email test is also there inside the message. We have successfully added a new subscriber which is using the JSON email format and it automatically gets emails. Now in your application, you might also want to do other processing based on these events. Now you could create other subscriptions. So let's see how we can create an AWS Lambda subscription so that we can trigger off an AWS Lambda function anytime you receive a message into this SNS topic. So let's come back to our Visual Studio and first create a new AWS Lambda. So let's open the Solution Explorer, right-click the solution and click Add a new project. In this case, I will use the AWS Lambda project and select Next. You can also search this from the list inside here. I have this template here because I have installed the AWS Toolkit for Visual Studio. Now if you're new to AWS Lambda, I highly recommend checking out my video on that, which will be linked here and in the description below. So let's click Next. Let's name this as Weather Data Processor and click Create. Now this gives us an option to select a basic template to create this Lambda. So in this case, let's use the simple SNS function. This will automatically have code that can listen to an SNS function. So let's click that and click Finish. This has created the new project. We have the AWS Lambda tools, which is the file that's required to run a mock Lambda test tool, and the function.cs, which is our main function. Now this has some methods in this already, which has the function handler, which will be the method that gets invoked when a new event is there. Now this automatically uses the SNS event as the object payload. This is because we use the SNS template to create this function. Now this comes from another NuGet package, which is the amazon.lambda.sns events NuGet package. Now all of this is automatically set up and it processes the message based on the records that it receives. Now all it does currently is use the context.logger and log this information. So let's leave all this defaults so that it will be logged to CloudWatch when we run a new message. So let's open this and deploy this Lambda into our AWS. So let's select Publish to AWS Lambda, which is again part of the AWS Toolkit. Now this has the handler automatically wired up. I highly recommend checking out my video if you are new to all this, where I walk through this detailedly. So let's simply give this a name. So let's assume this is to trigger off some business processes when a new weather data is created. So let's name this as business-process and say weather-data. Now this Lambda is running on .NET 6 Lambda runtime, which was very recently published. Let's click Next and select a role name. Now by default, let's give this as the AWS Lambda basic execution roles, which also gives us permissions to write to CloudWatch logs. So let's select that and select Upload. This is going to upload this Lambda into our AWS account. Now I had already set up my profiles to connect to Visual Studio. which is why it is by defaultly publishing to the same account that I have just created the SNS topic in. Now it's successfully published. So let's come back to our AWS console. Let's go to this IAM. Let's search for Lambda. Here you can see the Lambda that we just published. Now we can navigate into this and create a new trigger for this Lambda so that it will be triggered whenever a message comes into this SNS topic. So let's go into configuration. Let's go into triggers and select add trigger. Now here we can choose SNS as the trigger source and select that. We can specify the YouTube-SNS topic that we created and click add. So anytime a new message comes into that particular topic, we have a new subscription to this particular Lambda. Now once we go back to the simple notification service, go into that topic and refresh this page, you can see the new subscription that we just added, which is the business process weather data. We already have the Mailinator as another subscription. So with these two subscriptions created, let's come back to our application and run this and send a message again. Let's click post. Let's say try it out and let's specify the message as test Lambda and click execute. Now this sends the message successfully to the topic. So let's come back to our email. We would have received another email with this new data. So we can see this message, which is test Lambda. Let's come back to our Lambda function. If we go into monitor and go into the CloudWatch logs, we can see the log statements. Now by default, when this Lambda was using the console.logger, it was outputting this information to the CloudWatch as well. So if we come back here, select this new record, we can see this Lambda function is also triggered. Now here you can see this message, which is test Lambda, which is by defaultly written by our console.log statement, which is defaultly logging the message. Now this function is currently just logging, but based on your application, you could run your business processes, connect to database, or do anything else that you want inside of this function. Currently, whenever we publish a new message, this is received by both the Lambda and also in the email. So by default, the subscriptions receive all the messages that's published into that topic. However, Amazon SNS supports message filtering. By specifying a filter, you can decide which messages that a subscriber wants to listen to. Now, a filter is simply a JSON object which contains different attributes that will be used as filters on the messages that is coming into the topic. Now, when you create a subscriber, you can specify the filter. You can also modify the subscription to create new filters for that subscription. To see this in action, let's create a new Lambda function. So let's say anytime we publish a new weather data event, if it's for the month of February, we need to run some reports. For everything else, we just ignore it. Now I just chose February because that's the month that I'm recording in. Now it could be anything based on your application needs. So if we come back, let's modify this function to specify processing reports and log this same message. This is simply to distinguish between the two Lambda functions. Let's open the Solution Explorer, right click and specify publish to Lambda. Now if I give the same name, it's going to override the existing Lambda. So let's change this name so that this creates a new Lambda. So let's say reports-weather data and click next. Now this is going to create a new Lambda inside our account. Now you can see this is also selected with this region US East. Let's select the same roles. So let's specify AWS Lambda basic execution role and click upload. This has successfully uploaded a new Lambda. So let's come back into our console. Let's go to the functions. We can already see the reports-weather data. Now you could go and create a new trigger from here, or you can also come into our simple notification service and create a subscription from here. So let's select this. Let's specify the Lambda as the protocol this time. So let's choose AWS Lambda. Let's specify the endpoint. For this, we need the ARN of the function. So let's switch over to the reports and copy this function ARN and use this inside here. Now here you can see there is a subscription filter policy which can be used to create filters. Now this is simply a JSON object. So let's specify a JSON brackets. Let's specify a property, let's say month, and say that this has to be in a list of values which currently includes only February. So only if the month is February will this be triggered for this particular subscription. Once that is set, let's say create subscription. Now this creates a new subscription with this filter policy attached on the month being February. Now if we come back to our Lambda and go to the configuration and refresh this, you can see this will automatically have this SNS trigger. Now that we have set up this, how will this message know that there is a month property? For that, let's come back to our code and update the request object. So let's go into the weather data controller. In the request, let's add the message attributes and add a new attribute. So let's specify the key, which is going to be month in this case, and create a new message attribute value. So for this, we'll have to specify a couple of properties. So first, let's specify the data type and specify this to be string. And then let's actually specify the value, which is in the string value property. Now our data, which is the weather forecast, already has a date object. So let's simply use the toString and specify the MMMM, which is the full month name. In this case, whenever it's February, it will log out as February. So once this message attribute is added, we can send this message as before. So let's put a breakpoint here again. Let's press F5. The application is running. So let's come into the weather forecast, try it out. By default, the month is 02. So let's click execute. So this adds a message attribute. So let's expand this to make sure this is adding the month and also the value as February. So now let's press F5, which is going to send this message into our topic. So now if we come back to our mailinator and go back to the inbox, you can see the new message that's added in here. If we come back to our CloudWatch Lambdas, which was the first one that we created, this also has picked up this particular message. So if you go into that log, you can see the new message that we have just sent. So now if we come back again to our reports weather data, go into monitor and click view CloudWatch, we can see this also has a new record because this message was for February. Now let's say we go and publish a new message that is not for February. So let's update this and specify 01. Let's update the string. So let's say no reports just to make this clear and click execute again. Let's continue the execution and let's come back to our CloudWatch consoles. Now let's go to the mailinator first, back to inbox, and we can see this new message is here. Now this is the summary has no reports. If we come back to our first Lambda, which is the business process weather data, and refresh this, we can see this has also picked up that particular message. So you can see the no reports message has come here because both of these doesn't have any filters applied. However, if we come back to our Lambda reports where we had the filter and refresh this and go into this log group, we can see this has not been invoked for this particular message. This is because the filter has kicked in and filtered this message out. Since this is not belonging to February, it doesn't pick that up. Now, as soon as we send a new message for February, this will again get picked up. So let's say 02. So let's remove this no reports and click execute. So if we come back to the CloudWatch and refresh this, you can see that new message has just arrived here and being processed by our Lambda function. Now SNS has few filter policy constraints. Now for the string data type, the attribute comparison policy is case sensitive. So you need to make sure you're appropriately adding the correct filter attributes and values inside that. You also have certain limitations on the values that if you're using a numeric policy, and the total combination of values must not exceed 150. Now if you have these many combinations inside your filter, in here we have 3 different properties that's being looked at, but each of them has different sets of values. Now you can see the first one has 3, the second has 1, and the last one has 2. Now the total combination in here is 6. So this should not exceed 150. Now this is a very high number and it's very hard to exceed this. Now if you have to exceed this, you can create different subscriptions and move some of these filtering conditions to that and make sure you have 2 subscriptions for that. When we wrote our first filter, we added a simple string equality inside that, and we only added one value. But since this was a JSON array, you can specify multiple values inside this. So if you want this reports to be run on February and May, you can put comma and specify May. The filter policies also supports prefix matching. So if you want to add any values that has a specific prefix, you can specify that. Now if we say prefix MA, it's going to pick up all the months which starts with MA, which includes March and May as well. Now in this particular case, they're specifying BAS as the prefix, which picks up baseball and also basketball. However, rugby will be ignored because it doesn't start with BAS. Now, there's also other operators that you can use like anything but, which means it will exclude anything that we have specified. So in this particular case, anything but rugby or tennis will be allowed into the subscription. So if we send baseball or football, that matches and it will be picked up by the subscription. However, if we send rugby, it will not be picked up by this subscription. You can also mix and match, so you can use anything but and the prefix option as well. Now you can look at this documentation to see the different capabilities that this SNS filtering provides. I'll make sure to put this link in the description below. Now you can also use it as numeric values and use numeric comparisons. So you can use equality, greater than, less than, etc. properties to value compare numeric values. You can also use the exists operator to check if a specific property exists. So in this particular case, this is actually checking if a property called store exists or not. Anytime we create multiple attributes, this is considered as an AND option. So whenever this message is there, it has to cater for both these conditions, which will be an AND condition. Within this, it can take it as an OR. So you can see the OR logic is basically within each of these properties. Now, if you need to use OR option between multiple properties, your best way is to create different subscriptions. And you can point it to the same Lambda if that's what you want. Anytime we make an update to this filter policy, it takes some time, maximum up to 15 minutes, to replicate this across the whole AWS infrastructure. So whenever you are updating the filter policy, make sure there will be a slight delay to see this in effect. When a message comes into SNS, it will automatically deliver this into the subscription. Now for some reason, if this delivery is failed, it will automatically retry. Now AWS SNS defines a delivery policy for each of the delivery protocol. Now based on the subscriptions protocol that we have, it will have different ways to retry. You can look at this table to understand what they are. Now if we come back to our simple notification service, if we go into our topics and select YouTube SNS, you can see the delivery retry policy inside here. You can also edit this for this particular topic. Now you can see that that's one of the sections where we skipped earlier when we created and which was optional. So looking at that, you can see the number of retries is 3 and the minimum delay and maximum delay is 20 seconds. Now you can modify this to choose your application needs. You can also specify the retry backup function, which specifies different options inside here. Now, anytime the SNS is failing to send this message, it will automatically retry 3 times and try to send this message. Now, these failures could be of different reasons, because of an invalid subscription or because of an invalid endpoint or the subscriber does not exist, etc. Now, whenever SNS completes its 3 retries, it will automatically ignore that message. You could also choose to send this message into a dead letter queue so that we don't miss these messages. A dead letter queue is an Amazon SQS queue that an Amazon SNS subscription can target for messages that can't be delivered to subscribers successfully. Messages can fail because of client-side errors or server-side errors. Now, client-side errors is when it has a stale subscription data, which means the subscription is no longer valid, and server-side errors can happen when the system responsible for these messages becomes unavailable. Let's say we have an HTTP endpoint which no longer exists. So to set this up, we'll first need to create a new SQS queue. So let's come back to our AWS console. Let's open this in a new tab and create a new SQS queue. So let's select the simple queue service and create a new queue. Now this again is standard. So let's name this as YouTube SNS-DLQ. Let's leave all the options as default and let's click Create Queue. Now this creates a new queue inside our account which we can use from our SNS service. So let's come back to our SNS. The dead letter queue is assigned at the subscription level because that is where it could fail delivering a message, because we could be able to deliver the message to an AWS Lambda, however we might not be able to send it to an HTTPS endpoint, which are two different subscriptions to the same topic. So if we come back to our YouTube SNS, let's go into one of our subscriptions, let's say the report one that we just created, and select the redrive policy dead letter queue. Inside here, we can set up the undelivered messages to be sent to a dead letter queue. So let's click Edit. Let's say Redrive Policy and select Enabled. And we can paste in the SNS DLQ that we have just created. Now all this sets up is this dead letter queue to be the queue where messages should be sent if it's not able to deliver messages to this subscriber. So let's click Save Changes. Now this shows an error warning which specifies that the SNS should have access to this new SQS and be able to send messages to it. So let's come into this SQS, let's click Edit, and let's modify these policies so that we can send messages from our SNS to this SQS. Now I have the policy already written, so let's put a comma and paste that in here. I'll walk you through this. So all I'm doing is specify the effect allow, specifying the principal as sns.amazonaws.com because that is where this is being sent. This is associating the sent message action and giving access to this particular resource, that is the YouTube-SNS-DLQ. Now you could have a dead letter queue that's specific to each of these subscriptions or have one and have all of this captured in there. Now this basically depends on how your team plans to process and reprocess these messages from this queue. Now this is also specifying a condition where the source ARN should be the YouTube SNS queue that we have created. So with that set up, let's click Save, which creates access to this particular queue. Now with the dead letter queue set up for this subscription, if a message is failed to deliver to this particular subscriber, then it will come into the dead letter queue. When we are using Lambda with SNS, SNS delivers the messages to Lambdas asynchronously. So if there is an exception inside the Lambda, that is not considered as a failure to deliver the message, because from the side of SNS, it has successfully delivered the message to the Lambda. Now, if a Lambda fails because of any downstream issues or business processes or network connectivity, we will need to handle that at the Lambda level and not at the SNS level. Now, the SNS dead letter queue will trigger in only if it's not able to deliver this message to the Lambda in the first place. Now this could happen if there is an infrastructure issue in AWS, or let's say we simply deleted the Lambda function, which leaves the subscription as a stale subscription. So let's see this in action by deleting the AWS Lambda, because I cannot create an AWS infrastructure failure right at this point. So let's come back, let's go to the functions, let's click this reports weather data and select actions and delete this Lambda. Now this still leaves the SNS notification subscription intact inside the subscriptions. So if you see here, we still have the reports weather data subscription. However, this is a stale subscription. Now if I come back to our application and send a new message, let's say DLQ testing and specify execute. Now this is going to send a new message. Now since this is for February, this will be filtered and coming to that subscriber. So let's come to the SNS, let's go to the SQS, let's go to send and receive messages and say poll for messages. We can see the message that's come here. Now this message has come into the dead letter queue because the SNS is not able to deliver this message to our reports Lambda function, which we just deleted. So if you click this, you can see the message that we have just sent, which has all the data and the subject, which is new weather data, and specify DLQ testing. Now based on your application and business processes, you can reprocess this message by sending it to this particular subscriber again. In this case, you will have to deploy the Lambda function again and send it to reprocess that. I hope this helps you to get started with Amazon SNS from a .NET application. We learned how to create a topic, send a message to the topic, and use subscribers to receive these messages. We learned different ways using emails and also Lambda functions to receive and process these messages. Now we also learned how to apply filters on Lambda subscriptions so that you can just receive the messages that you are interested in. This helps us to reduce the number of messages that we have to process per subscriptions. We also learned how to set up dead letter queues for the subscriptions and how this works from end to end. If you like this video, please make sure to hit the like button. If you have any questions, comments or feedback, please make sure to drop them in the comments sections below. I make sure to reply to you. If you want to be notified of future such videos, please hit the subscribe button. It'll also help me to grow this YouTube channel. Thank you and see you soon.